All right, everybody back? Welcome back, folks. The next talk is called Surface, a bridge to the JavaScript community. And up here we've got Dave Lucia. He is a VP engineering at SimpleBet. For the past 5 years, Dave has been working with Elixir as his primary language, coming up from the JavaScript and Node.js community. Take it away, Dave.
Thank you, everybody. Please give it up for Marlis, who just gave a great talk. Marlis. Oh, and before him, and all the other talks today, it's been great. Again, my talk is called Surface, a bridge to the JavaScript community. So I gave a talk at ElixirConf back in October, and this is where I went through kind of the progression of, for the last 10 years, really how we've gone from early JavaScript frameworks like Backbone to React and Vue. And I talk about some of the unique features that Surface really learns from. I don't want to talk about that today. I want to do something new and interesting. So if you want to look at that talk, check out my ElixirConf talk. Today we're going to get a little bit more hands-on. So what I want to do today is I want to walk through building a real project with Surface from start to finish, sort of. And I want to demonstrate the power of Surface through example. So when I was thinking about this talk, I was originally like, oh, I'll just rework my ElixirConf talk and that'll be great. And I was like, oh, okay, that's boring. Let's find like a project that I could build. And so I was reaching around, I was talking to friends, and I reached out to my friend, Todd Resadek, who's here in the audience. And I was like, Todd, you have a lot of really cool projects that you do on the side. You know, is there anything that I can like borrow from? So he's like, yeah, Dave. He was like, have you heard of my project? It's called Humid. I'm like, all right, Todd's got like a sprinkler thing that he's built, you know, hooked it up with nerves. That's really cool. Maybe that's it. Humid, water. It's like, is it your smart mirror? And turns out, no, Todd has another project with Elixir and LiveView, and it's called Humid. And it sits in his office, and what it is it has a calendar. It's got kind of like the temperature and the weather. It's got some cool stuff. You know, Todd is organizing MPEC's Mountain in Salt Lake City later in May. And it's got some cool stuff for, you know, number of tickets sold. So I was like, this is a really cool project. I bet we could build this, and that would be a fun one to work with. So I was like, what does Humid stand for? It's like, it's called the Heads-Up Multi-Informatic Display. Duh. So thank you, Todd. Now, I'm no stranger to taking Todd's work and rebuilding it. About 2 years ago, Todd built a SpongeBob CLI that takes, you know, normal text and makes it sarcastic SpongeBob text. He wrote that in Go, and I didn't think that was fast enough, so I rewrote it in Rust. So the SpongeBob CLI was born. We'll come back to that later. So this is what we're going to build today. It's called Dash. Dash, it's got clocks for different time zones. It can display stock tickers and show, you know, what's up or down for things you care about. It's got a little agenda going so that you can see, you know, what are you doing for the rest of the day. And then maybe a little bit of a notes application so that, you know, just as Markdown, drop in some notes and see that, you know, just up on a display in your office. So, cool project. Oop. All right, so let's talk about how we're going to even start this project. So the first thing we're going to do is we're going to start it like any other Phoenix LiveView project. We're going to type mix Phoenix new. Name of the project is Dash. We're not going to use any database here, so no ecto. Now to bring Surface into the project in particular, Surface has a really cool way of injecting code into an existing project. So while Phoenix has the Phoenix generators, which are EEX templates and is injecting via string interpolation, Surface uses a project called Sorcerer, which actually understands the AST of your existing Phoenix application, uses that to modify your code to inject Surface into it. So I ran that, typed mix Surface init, added dash dash demo and dash dash catalog, and now we've got something that we could start to build components with. So catalog is something that Marlis just talked about in his Surface talk. And now we're going to go actually really deep on the catalog and see why it's so powerful. So this is what the catalog looks like. And my talk is called Surface, a Bridge to the JavaScript Community. Something that's really powerful in the JavaScript community is this idea of a style guide. So there's a project out there called, I think it's Storybook.js. And what it allows you to do is to write components and to configure them into different states, and so that you could work with a designer, and that designer can see your code, see your components, and be like, okay, this looks correct, this is the right color, this box is in the right place. That's what the Surface catalog is. It's a way of demonstrating, documenting all of your components all in one place that you can interact with. All right. So this is where we're going to move into the live coding portion. So here we have Dash, and you saw the final product before. We're going to start to build up some of those components. In order to do this, and in order to not write code right in front of you, I've built a code navigator. And let's inspect that through the component catalog. So I can see my list of components, and I've got a code nav. And the code nav allows you to navigate between different Git tags, and it's for demonstrating the progression of code changes during the presentation. Now note that I don't have any visual indication of this component, but I can see that it takes an ID, thus it's a stateful component, and I can kick it off to another branch. All right, and if we look at the code navigator, we can see the different Git tags when it mounts, and I can select between different tags, and then it's going to do a Git switch, which is like a Git checkout, and it will check it out to a new branch. So the first thing that we're going to build is the clock component. So we're going to see that here, and a clock component is a component that represents a wall clock. Now let's open up that clock. So I don't have anything here of interest, but if you notice, the module doc that I wrote is the module doc that you see in the catalog. I'm going to go ahead and sit down. All right, so let's start to build this component. So now I'm going to add some properties to this clock component. Let's see here. So now we got one property, a clock takes a time, right? So with Surface, you can annotate module components, and you could say this is a property. So the property's name is called time, and that's how it will be passed through as the assigns. It's of type time, and it's a required property, so if I don't pass it, it's going to raise an exception. Now, because we have this declarative API for properties, you could see this in the public API in the documentation. You can see it's of type time, and it's required. All right, so now we're starting to implement the component. And let's actually look at what we call an example first. So once this refreshes. So components, you want to be able to see things in different state, right? Typically when you're maybe writing something in LiveView, you're going to start to iterate on a component, you're going to write some classes, and you're going to have to maybe click a bunch of menus and get the components back into the right state so that you could see that what you actually implemented is correct. That's not really a great feedback loop for when you're working on stuff. And so what Surface allows you to do is to write out examples. So here on the right side, I have 3 clock components, each with different times. And on the left, they're being rendered, and we could see that they're correctly rendering military time clocks. Now, in order to create one of these examples, I'm going to pull this up right here. So all I do is I declare a example, in my priv directory, I say the catalog that it belongs to. I say the subject of this example, which is a clock. And then I just render out the 3 components. And what Surface is going to do, it's going to take this, it's going to display this code, it's going to format it, and then it's also going to render the components. And so that's exactly what we're seeing here. Now, for Dash, I don't really read things in military time, so let's augment the API of this clock so that we have standard time as well. All right, well, actually, I missed a step, but that's OK. So now we want standard time. And the way that we're going to do this is we're going to accept a format on our clock. We're also going to create a new example. So this new example is going to be clock standard. And it's going to do exactly the same thing, but now we're going to pass the format as standard, and we're going to pass these series of times. And in the component itself, we're declaring this new property. It's format. It takes an atom. And the atom, I can declare it has to be of either standard or military, and it's also going to default to standard. Now, Marlis just talked about how there's a DSL in Surface that is not exactly Elixir and that it's particular to writing HTML. So here we're seeing an example of that where I have a case block, and it's not so different from normal Elixir, but what it has is just maybe a little bit more concise way of writing this case statement. Now, the really interesting thing is that now I have 2 different completely separate instantiations of these components, and I can see side by side that they're working correctly with this really nice documentation. So my military time clocks continue to work just fine, and my new standard clock times also work, but with different formatting. All right, so these are like very boring stateless components, but let's make it a little bit more interesting, and let's build a stateful component, a clock that can tick. So first thing we're going to see, we're going to add the existing clock to our dashboard, and it's passing just the current time in UTC, and that's 9:13, which is 5 hours ahead, so about right. But it's not ticking, it's not doing anything interesting. So let's take a look at the ticking clock instead. So a ticking clock is a stateful clock, and it can receive tick updates. Great. It's going to pass an ID because every stateful component needs an ID, and we're going to pass a time zone. A time zone is just going to be a valid time zone string that you would expect to see in like the TZ data time zone database. And let's look at this component now. So the ticking clock is a Surface live component. We're documenting the module documentation so we could see it in our catalog. And all it's doing is wrapping the clock that we just built, but it's taking a date time. And notice that it says data, not prop. What this is a way for Surface to allow you to annotate internal, like kind of private data. And this is really helpful for, as you're iterating on your components, that you could see, exactly the properties that are going into your components. So we have the clock, we're shifting the date time, and we're assigning it as new. So if we render this clock and it doesn't have a date time, fine, it goes to assign new. It calls this function, which gets the current time in UTC. It's got a little function which is going to pull off the last part of the time zone string, and it's going to shift the date time right to that new time zone. OK, cool. Let's look at this maybe in a little bit more interesting way. So before we saw examples where I pre-baked a series of components in particular state. But maybe let's think about it more from like a property testing standpoint. So I want to be able to play around with this clock and be able to test it. And this is what a playground is for. So here I've declared a playground, and I see that it's 5:13:50, the current clock, and I can click this tick button. And as I click this tick button, it's sending those tick events, which will update the clock. But more so than that, I can also edit the time zone. So let's change it to the time zone we're in, which is Chicago. If I could spell it right. And boom, we've got the current time. So that's pretty cool, but what's even more cool than that is that the Surface catalog gives you debugging tools, so I can run the garbage collector on the process. I can also inspect the assigns that are being passed to this component. And I could get the built-in assigns, also the private assigns. And then if I go to this debug and profile, I can inspect the JavaScript console, and I could also see, as I interact with it, exactly how LiveView is patching the DOM in order to pass new information. So if I could drill into this correctly, I could see, look at this. This is the current time, because this is split across 3 different spans, and it's getting all of that information. So this is really helpful if I'm iterating on a component. I don't want to bring it into the dashboard yet. I just want to see how things are working. I can see all the states, see all the different visual design things. Maybe my text is too large or whatever it is. And I could also memory profile it and see all the assigns all in one place. That's super powerful. Creating the playground is just as easy as the example. So this is the playground for the ticking clock. So I just declare my clock as I did before, and the only other thing is that I wanted to be able to send ticks to my component, so I add that little button and I call a tick. Okay, very cool. Let's take a look now at the dashboard. So we've got this clock. Let's make this work so that it's actually sending a tick to the clock. So first, let's look at the code for the dashboard. So the code for the dashboard, it's got the clock, it's hard coding the time as UTC. At the moment of rendering, it's just going to set that, and it's never going to change unless you reset or when it hooks back in. So I'm going to change it. And now I've sent it. Now I'm going to be sending it ticks. And what I do is in the mount, I check if I'm on the connected LiveView, and I'm just going to send a timer interval every second. And it's going to send a tick, and I'm just storing the clock as the time zone, and I pass that as the ID, I pass that as the time zone to the clock, and as you can see, the time continues to tick on the clock. Now, this is New York, we're in New Orleans, I've got friends down in Uruguay and Montevideo. For my dash that I'm going to put in my office, I want to see multiple clocks. This is really easy. It's really easy because I've already done it, but okay, so now we're sending 3 clocks, 3 different ticks. How many lines of code would this be in LiveView? I don't know that it's actually even really the point. The point is going back to the ergonomics of Surface and how it thinks about how you can output HTML in a way that's really concise, easy to read, easy to understand, easy to work with. So all that I changed was in the assigns, rather than passing a single clock, I pass a list of clocks, still sending the same tick clocks on the timer. Now, instead of sending a single tick, I just loop over the clocks and I send a tick for every one. And now here's kind of really the crux of it. So this ticking clock, I didn't change this line at all, except I added this little for comprehension right here. And this for comprehension is taking from the assigns, the clocks, it's looping over it just as it would in a normal for loop, and it's passing this as like a for comprehension as you would normally do in Elixir, but directly to that clock. So this is a way to be like, okay, there is an innumerable things here. I want to render this multiple times, but I don't need to spread this logic across 10 different lines with all these different things in between. Let's minimize the line noise and let's just focus on what's important, which is showing these clocks. All right, so we could tell time, great. Let's move over to stocks. So let's come back to the example here. And I'll start by showing you the clock component, or the stock component, I should say. So a stock is a component for showing a stock price and a daily change. It has three properties. It takes a symbol, for example, GameStop. That is a string. It's required. You have to pass it. It's also going to take a price, which is a number. It could be an integer. It could be a float. We don't care. It's also going to take the percentage change for how much that stock has changed in the day. And then we're just going to render it out. So there's nothing really too interesting happening here. The one thing that we're going to do is we're going to format it so that the percentage looks nice. Now, again, I'm a developer. I'm working with a designer, or I'm working with just other engineers on the team, and maybe they need to integrate a stock component somewhere on a UI. Well, now look at this documentation. I barely did anything, and I have this great set of resources that I could look for whenever I'm like, I need to interact with this component. Maybe there's a property that is not being used elsewhere in the code base, but I could see exactly the type, exactly the defaults, and exactly the intention of each property. But what's more than that is with the power of the examples, split across 3 different files, I have these examples, and I can now show what the stock will look like when it's down. I can show what it looks like when it's up. And what I can get from this, I go back and forth. I've cataloged all these different states, and I talk with my designer, and they're like, we really should add some color here. Okay, so now we could see, and hopefully not so fair to anyone who's colorblind in the audience, but it's red when it's down and it's green when it's up. And what I really wanted to highlight here is, again, going back to the DSL of Surface, where it's just so common to be able to pass a certain property, and depending on whether something is truthy or not, you need some logic that's going to decide whether or not I want to apply a particular class. And here, Surface, when you pass a class, you could pass it as a string as normal, which is totally fine, totally reasonable. You could wrap this in curly braces, and it would do the same thing. But what you could also do is you could pass a keyword list, sort of a keyword list, it's not exactly, and anything that is truthy on the right, it's going to end up applying that class, and anything that's falsy on the right of the value of the key value, it's going to not apply it. And this line is exactly how I implemented the red or the green. Now, coming back to the playground, this is a great way of testing all of the various states. So maybe you've written out these examples, but you kind of want to see how it transitions, because the stock is going to go up and down. And that's just something that you could play around with here, where I can make the price go up and down. Let's see what happens when I set it to 0. Great, it works just fine. And same thing for the percentage. I can move it from negative to positive, and it all changes just fine. We've got stocks. They're not updating, but we'll pretend for today. Let's move on to now our agenda. Okay. So an agenda is going to take a list of items for today. Those list of items are going to be they're going to be maps. They're going to have a name, which is a string, and they're going to have a time, which is of type T. I want to be able to limit the number of items that I show. Maybe I don't have a big list of things to do today. I don't want to show everything. So I can easily apply that limit. And I'm using now this different style of a for loop, where it looks more like the Elixir for loop. And I'm going to format some time. No big deal. There it is. So maybe this is a place where contributions to Surface would be great, because we can only specify a list of items, but we can't specify that it's a list of items that has this name and this type map underneath it. So some things that I'd love to see brought back to Surface or coming there in the future would be more extensive type validation, where if you pass something that does not align with the type that you say, that it can give you really helpful error messages about, hey, you're trying to use this component in a way that it wasn't intended to. And going back to this agenda items, I've got all these examples, and I could show these things in different states, and I could see, before I integrate it into my application, I've got a small agenda list, I've got a big agenda list that I think this has like 10 items, and I limit it to 5. Really excited to get that shrimp etouffee and those hurricanes later, Chris. And I can also see what happens when I don't pass anything. And so in this case, I just have a completely empty agenda. Maybe that's fine for your design constraints, but maybe you want to show something when there's nothing to do today. Now, how would you do that typically in Phoenix LiveView, or really any other templating language? We'd probably, after this for, maybe we'd stick an if block at the end and say, okay, if items is equal to an empty list, we'll say nothing to do today, right? But this is exactly where Surface tries to give you more power, because there's certain just patterns that are really common that happen all the time when coding, and there's no reason why we can't have a DSL that helps in that way. So with Surface, you can apply an else to a for loop, and this else is going to have just completely different text than the body of the for loop, and it works beautifully. All right, so let's move on to our last component, which is our notes component. And I'm going to show you how we're going to integrate it first. So this is a dashboard. It's just for me. I could have some CMS where I go in and I type in a form and I, hit publish, and it's going to update my notes for today. But I don't need to do that, because this is just going to run on my local computer. So I want to be able to type in some notes in Markdown, and I wanted the Markdown to be able to be rendered. So I've created this notes component, and I put some Markdown inside. So, okay, I have some things to do today, which is like a headline. And then I have an unordered list in Markdown, so I'm going to go to the Big Elixir, already did that. And I'm going to eat some beignets until I explode at Cafe Du Monde. So I've got a sarcasm block in here, which is my own HTML, but point being is that HTML is supported in Markdown. So if I look at this right now, it's not exactly doing what I want it to do. First of all, it's not rendering the Markdown. I could see this unordered list as is. And two, if I look at this HTML, I could see that sarcasm block is just rendered as is, which is obviously not what I want. We want to render this as Markdown. So let's look at this notes component and see exactly what's going on. Okay, so I've got the notes component. I'm just going to be rendering a div, and then inside of it, I want to render the slot, which is whatever you passed into the body. Now, how might we take what's ever passed in the body as the slot and modify that? If we look at Phoenix LiveView, you could call render slot, but that's not really giving you access to kind of what you need to do here. Worse than that is that because the sarcasm block is valid HTML, we're not going to be able to access this because the parser is going to parse it and treat it as AST before you're even able to access it. So we need a different way. So what Surface is going to offer us here is something called a macro component. And a macro component is exactly what it sounds like. It's a macro. It is going to take whatever you're passing to it at compile time and give you all the facilities that you have at compile time in order to make modifications. So in our case, we want to take what's coming in on the inside of this, this notes component, and we want to be able to run it through a Markdown compiler. So to denote on the component integration side that it's a macro component, we throw this, this pound sign in front of it. And then on the component itself, so now I've changed this to be a use Surface macro component. And we're going to use, I wrote, because I was avoiding writing slides, I wrote a small Markdown compiler for this presentation. We're going to use my Markdown compiler. And just to demonstrate, how it might be used, we're going to pass it through and, just call it as pass through a AST literal, which is going to pass through exactly what it is. So this is just demonstrating right now that this is now a macro component, but it's still not doing the thing that we want. So now we're going to pass it to be, boom, look at that. So now it's rendering it as a list. We've got special syntax or special treatment, visual treatment for the sarcasm block. And if we look here in the DOM, it is no longer rendering that sarcasm. It is a span, and it's setting it as italic with text blue. We're using Tailwind here. And that's all very cool. And what's happening is that we're just passing, just as we were before. Let's zoom in on this. The AST literal, we're just passing this through, and this is just Phoenix LiveView and Surface just kind of shoving this HTML down to the client. Now, for fun, let's take a look at this Markdown component and see what I did here. So for the sarcasm, this is really simple, and it's just a regular expression. Whenever it sees the sarcasm, it's just going to do a straight regex replace and put the text inside. Now, on the Markdown side of things, I implemented a Markdown compiler for a list, and this is like the very basic start to replacing a Markdown compiler. But I was thinking to myself, okay, we've got this dashboard. Maybe it's not as cool as the one that Todd has in his office, but when talking to Todd, I was like, Todd, how could I bring this up to the next level? How could I make this more interesting? He's like, well, why don't you just, if you're doing this at compile time, why don't you, call a Rust NIF and call the SpongeBob CLI at compile time, and then you could have SpongeBob text on your dashboard. So naturally, because I still didn't want to finish my slides, I wrote a Rust NIF that calls the SpongeBob CLI. So now if we refresh, you'll notice that because it's compile time, if I continue to refresh, the randomness of the SpongeBob text will not be in effect. Absurd. And just to prove that it's a NIF because it's silly, here's the NIF. It's using Rustler. It delegates out to the SpongeBob speak. And thank you on password. And we could go through that if we have extra time. But OK, so now we've got our whole dashboard. And maybe let's come back to the slides now. All right, so I brought you through this exercise of building these simple components and kind of just getting like a taste of some of the DSL. There's so many other things I didn't cover, context, the surface formatter, a lot of other elements of the DSL, ways that you can interact with events. There's just so many other things that Surface provides. But I want you to leave here thinking that there are certain things that Surface focuses on that are really about the developer experience, about the ergonomics. And there's just so much that I get every day working with Surface. We use Surface at SimpleBet, and it powers multiple of our products and internal tools. And I find that we get so much value out of having these additional features on top of LiveView that you don't just get out of the box. So Marlis already covered a lot of this, but things like Heeks, slots, the formatter, the declarative property interface that will be coming to LiveView soon. These are all ideas that were started in Surface. And they've made their way back to LiveView because I think there's a certain universality to them in that they've really taken wisdom from years of JavaScript iteration and are really trying to bring them to this community. I love working with Surface, and I think that as a community, we have to be careful about aligning on single solutions because that gets us all thinking in one direction, which is a good thing, but it's good to have different opinions and to take them into account because that's where I think really interesting things come to be. So if you find Surface interesting, we've got a whole crew here who's working at SimpleBet on Surface. And I'm DavyDog187 on Twitter and GitHub, and thank you very much.